So yesterday, we ended off with dealing with this massive chunk of data. I don't know if it's really massive, but it seems massive. There's hashes and arrays all mixed up within each other. And as we'll see later today, a lot of dealing with APIs is dealing with data structures that look like this mess. So a good skill for us to hone is being able to work with this kind of data. Particularly, the exercises yesterday were to derive 4 specific pieces of data from this hash with our code. Now this data represents the current weather in Nome, Alaska, at least as of yesterday. So this was yesterday's weather in Nome, Alaska. There's a lot of gobbledygook in here, and it definitely takes some time to just even read this and figure out what's in here. Now, some things are self-explanatory, and some things, even to this day, I don't really know what these things are. Looking at some of this we can make out: distance, miles, pressure, inches, speed, miles per hour, temperature, F, which is probably Fahrenheit. The title is Weather of Nome, Alaska. Location, here we have Nome, Alaska again. We have this section called wind, which has its chill direction and speed. We have a section called atmosphere, which is its own hash that has humidity, pressure, rising, and visibility. Astronomy, which just includes sunrise and sunset. This thing called item, which has a lot more data in it, which buried in here actually is perhaps the most pertinent piece of information, which is temp. That is the actual temperature. So within all this data, to find the actual temperature of Nome, Alaska, as of yesterday anyway, it was 46 degrees Fahrenheit. And it was also mostly cloudy. There's also this thing called a 10-day forecast, which is this array of hashes. Each of these hashes is one of the 10 days for the upcoming days with its forecast. Now, before we get into the actual exercise, any questions about the structure? Again, at its root level, we have this variable called weather. This whole thing is that weather. It's a hash. Since the first thing here is a curly brace, that means that this data structure is a hash. Now it has a hash that has other stuff in it, like another hash and another hash. And somewhere in there, there's at least one array with the 10-day forecast. As you can see the square brackets. It looks like it's mostly hashes within hashes, though. Any questions about this? Okay, so now's the hard part, which is actually getting the data. Now remember my pro tip from yesterday, which I know a lot of you used when doing this exercise yesterday, but the pro tip here is the key, and that is checking out every piece of information one step at a time instead of trying to guess the whole thing in one fell swoop. So the first thing we wanted to get here is the wind chill. Now, the first thing we have to do here is actually look through this data structure and see if we can find where it's located. So this is it. So there's this thing called wind. Wind itself is a key. The value is yet another hash that has 3 keys of its own, 3 key value pairs of its own, including this thing called chill. So as a human, if you ask me what is the wind chill yesterday in Nome, Alaska, we can look here and see that it's 41. But now the challenge is to write this with code. So I'm going to zoom out a little. Yeah, this thing is just too big. So let's start with, it does seem like, I actually went through the trouble of indenting all this for you. Sometimes when you get stuff back, it's all one big blob. But looking at this indentation, it looks like everything is contained within this initial hash. And if we look up the query key, the value will be this whole big inner hash. So I'm going to start by saying P, we're going to print out weather query. Now if we run that, we do get this big blob back. Here, let me eliminate that. We get this big blob back, and here we don't have the luxury of having the indentation. But it looks like that the wind chill is in here. So this is good. We managed to get one step into this data structure, getting one step closer to the wind chill. If we couldn't see the wind chill in here, that means we probably went in the wrong direction. But now we stepped closer, and the wind chill is still in our sights, so we're going to get closer. Yeah, Joseph?
Can you explain why, in contrast to the other one where it was people and there was 3 people,
Yeah.
there was like the number of the index, right? So it was 0, 1, 2. But
Yeah.
we're not putting a number, an index, we're putting query, which is the first hash, right?
Yeah, so good question. So let me pull up the example you're referring to. So Joseph is referring to this example. Now here, when we try to get the first step in, we have to do people and some sort of number, right? The reason for that is that the outermost structure here is an array, and therefore everything is going to be at some index 0, 1, or 2, whereas here, the outermost structure is a hash. So with a hash, it's always going to be something. I mean, with a hash, the keys are very flexible. You could have numbers or strings as keys, whereas with an array, the key is always the index to start. It's like 0, 1, or 2. Does that make sense? Other questions? Yeah, that was a good question. Okay, the next thing we're going to dig into here.
Okay.
Yeah.
So is this the first step you would typically take for kind of deconstructing?
Yeah, well, if I was faced with this and I wanted to zero in, yes, the first step I would do is just exactly what I did. Yeah.
Yeah, I noticed later on we also use another array, especially when we're getting closer to the, say, the 10-day forecast section.
Yeah.
So going back to what you said about if hashes are included within an array, you can typically use the same like array numerical notation to return values from within the array.
Right.
Does the same go for arrays that are within a hash? So
Yeah, the rules with arrays and hashes are always the same no matter where they're found. So, like this right here is an array within a hash that's within an array. So to get at, let's say chess, I would do people 0, which gives me back, and you can see this, right, if we print it out. People 0 gives me back this hash. Now to get at this array, I need to call the key that points to it, which is hobbies. And now we've dug down, we've basically zeroed in on this array. So to get chess, now I need to get at index 1. So here we sort of alternated back and forth. We have, right, here we're referring to an array, so we call its index. Now that points to a hash, so now we pick a key out of the hash, and the value of that key is yet another array. So now we have to call a number to get at that. Yeah?
Maybe I'm jumping ahead, sorry, Jay, but I couldn't get this one to work without putting an array in first.
Which one's this one, the weather?
The weather one.
You put a number here?
Yeah, if I don't put 0 before query,
Yeah.
if I don't put a 0 there,
Yeah.
that doesn't work. So if I put a 0 there, yep, now it works. If I
So you must have some different setup than me, because
You did get query, I remember. It was after
yeah,
that.
query, but okay. Okay, so maybe I'm going too.
yeah, well, we haven't. The only time we're going to have to end up putting in a number is if we encounter an array, which we will do for one of the exercises. But so far we haven't encountered that. Yeah. Other questions? Okay, so now we still want to get at this wind chill, which again is here basically on line 25. But that's within these larger structures, which it's sort of hard to keep track of. So we've sort of tunneled in to this hash. Now, just looking at the indentation, it looks like the next key that we want to hit on is results. Look what happens, for example, if we decided to go with count. If we call count, the value that we're going to get is this number 1, right? So this is a dead end, right? We hit a 1. A 1 is just a number. We've got it back. But that's not where we want to go. We want to find we want to find the hash where we could find that wind chill. Now, this wind chill piece is contained within, and it's hard to look at this, and so I'm not even 100% sure myself. It looks like it's within, see, this is why I don't, let's not guess. Looks like results is the next key in, because the value of results is yet another inner hash. So I'm going to see what happens if I do results. So if we do results, we get an inner hash. It still is a big blob, but it's actually a smaller blob than it was before. And we basically are dealing with this hash that starts there. Now the wind chill is still there. Hard to find, but it's here. So we are still headed in the right direction. So the question is, where do we go from here? So it looks like channel might be the right key. And you know what? It doesn't pay to overthink it. Let's just try it. So with channel, we get back yet a smaller hash. Wind chill is here, so we are still headed in the right direction. So now we're dealing with this. Now it looks like, at first glance, it might look like units is the right key to pick, but I don't think it is. Let's just see. Yeah, so this is a dead end. Units is just simply a key to this much, much smaller hash that does not have the wind chill contained within it. So that's a dead end. So perhaps, can we go straight to wind? Maybe we're up to there. Let's see. Yeah, we can. And there's the chill. So when we got up to here, all we have back now is this very simple hash with 3 key value pairs. So now if we do chill, we get back the wind chill of 41. So this wasn't total trial and error, but it was a little trial and error. I mean, if you had to sit down with pencil and paper, you could determine, this is not a lucky guess, you could determine, in fact, exactly how to find wind chill. The problem is when dealing with this in reality, it's just hard for humans, for us to parse this with our eyes. There's just a lot of stuff. So that's why I do sometimes I do a little trial and error, and then back up a little bit. But if you did stare at it very carefully and use pencil and paper to track where you're up to, you could know for a fact exactly where to find it. It's just not worth the time and effort. You may as well just guess around a little bit. Any questions about this? I mean, the concept to get used to here is the fact that you could have a hash within a hash, or an array within an array, or array in a hash, or hash in an array. It's easier to think about, arrays are simple when it's a list of numbers, right? And a hash is simple if the key is a string and the value is a number. But when the key is a string and the value is yet another hash, things start to get really blurry.
Array of hashes, basically.
Or an array of hashes or a hash of hashes, and I mean, it's not inherently more complex, it's just harder for us to visualize.
Quick question. So with the query thing, right? And when query leads into a hash,
another hash, yeah.
Another hash, but then it's a multi-option hash, essentially. Is that right, or how would you conceive of that?
All hashes all hashes are really multi-option. Because a hash is a bunch of key value pairs. So basically each key is that option that you're thinking of. So if we have...
Okay. So it's just like the query opens up the list of implications that are later on different hashes.
That is the way to look at it, yeah.
Okay.
I mean, if just looking back at the wind hash, right, there's three choices where to go from here. I can go into the chill, I can go into the direction, I can go into the speed. Now here, all three values happen to be numbers, so this is where it all ends. But if one of those values was yet another hash, that's like another door you could step into.
I understand that, but
Yeah.
in this case, since it is literally three different hashes that are...
This is one hash, but with three different key value pairs. That's how you would say it.
Okay, rather than an array, because it looks like an array. Yeah, okay.
A hash is a list just like an array is a list, but a list is an array of single items, and a hash is a list of pairs.
Roger. Makes sense.
Now the pairs in a hash are very much associated with each other. They're not like two random items paired together. I mean, the fact is that chill and 41 are paired together because the wind chill is 41 degrees.
Right.
It's not without reason. I mean, you could make a hash that has random keys and values, but you would never do that in real life.
Right.
The point of a hash is when you have pairs of associated things that you want to list together.
That makes sense. Okay.
Again, a lot of this is simply getting used to it. So that's the wind chill. Any other questions about that? That was the first piece of exercise. Okay. The second piece is, I have no idea. Oh, getting the longitude. So the longitude is somewhere in here. It's right here. Now that's not too far, whatever. It's different than the wind chill, but we probably could steal a bunch of what we did for the wind chill to get into there. Okay, so we're probably going to start with query and channel again. So let's do that. Oh, query and results channel. I'm going to comment this out for now. So if we run this, we get this big hash that hopefully has the longitude in it somewhere. It does. It's right here. Okay, so the question is, where do we go from here? So we're in channel, so that means we're in this hash here that goes all the way down. It looks like item might be the right place to go next. So let's try item. So now we have a smaller hash, but it's still big. The question is, yes, so the longitude is still here. And in fact, it looks like we're really close. It looks like the next step is simply longitude. Yeah, so let's see if that actually works. Yeah, it does. So that was a little less painful, because we've already did like the more painful, or the similarly painful thing before. So that's the longitude. Questions about that? Now the nice thing about longitude is that it doesn't change on a day-to-day basis. So this was the longitude in Nome yesterday, but it's also the longitude today. The weather changes. Let's get the current temperature, or the temperature from yesterday. Now this one, we pointed out before, that's here. So this isn't too far off from longitude. We probably could go all the way up to item and start from there. So let's comment that out, copy and paste this. So we have this hash here. Is the temperature in there? It is. Now this temperature is a key within this hash. Now to get at this hash, it seems like we have to call the key condition. So let's see if that is indeed what we need to do. Yeah, so now we have this smaller hash. This is a hash whose values are really simple. They're either numbers or strings. So all we need to do at this point is call temp. And we should get our 46. Not there. No, not there. Yeah, so we got our 46. That's the temperature. I mean, again, it's a hash and 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 a hash. And a hash. it's very, very nested. But any questions about that? The cool thing is that like you've unlocked all there is to unlock in terms of this type of stuff. In Ruby and in APIs, all things are either arrays, hashes, strings, or numbers. There's nothing else out there. It's not like there's 6 other data structures you haven't learned about. I mean, there are other complex data structures, but not in APIs and not built into Ruby, and not things that you'd ever use in a real life basis anyway. I mean, this is it. Everything boils down to this.
So is this what your book talks about?
So my book talks about the more complicated stuff, which you don't really use in a real life basis. Which made writing the book very challenging because this particular publishing company, they're called the Pragmatic Programmers, and all their books has to have the angle of how it's practical. So I had to stretch really hard to explain how some of these more complex data structures are used in a real life basis.
But do they all consist of strings, hashes?
Do they all? No, these ones are sort of their own beings.
Okay.
Yeah, but like, and I've been a developer for a number of years. I don't think I've ever used any of those things from my book for real in any of my work projects. Whereas hashes and arrays are the bread and butter of what you do every day. Yeah.
Maybe you're getting to this, but could you explain? Some people probably know what it is, but an API, just succinctly.
Yeah, we're gonna get to API. That's coming up. So I've been alluding to it, but I haven't explained it yet. Today's primarily gonna be just about that. Yeah. Okay, one more exercise, and that is get the high for next Sunday. So that's part of this 10-day forecast. We can see there is Wednesday, Thursday, Friday, Saturday, Sunday. So the high happens to be 51, but we want to be able to express this with code. So, okay, let's see. This 10-day forecast is actually an array, which makes sense, right? It's a list of days. Each day is an individual object. Now, since a day has different attributes to it, each day is represented by a hash. But it is an array of hashes. It's a list of hashes, and each hash represents one of the 10 days in the forecast. Now, before we get to the 10-day forecast, how do we get to the 10-day forecast? So the 10-day forecast seems to also be contained within this item hash. So hopefully this will work. Let's see if the 10-day forecast is in there. It is. So I think we can just get at the 10-day forecast through this. Yeah. So here, this is the first time that we're seeing an array as the root object here, so the most outer object. So to get at any particular, so now that we have an array on our hands, and so now everything we dealt with was hashes in this exercise. But this is the first array. Now to get any item out of an array, you have to call it by its index. So, yikes. So Wednesday is 0, Thursday is 1, Friday is 2, Saturday is 3, Sunday should be 4. So let's see what happens when we get the fourth item.
There you go.
We have Sunday. So again, this hash is a simple hash in the fact that all of its values are either strings or numbers. They don't lead to any more arrays or hashes. So it looks like we can just call high and then get the high. We get 51. Any questions about that? Okay, we're going to do one just quick exercise just to get you back in this mode, because we're going to be doing a lot of this stuff when dealing with APIs, which we're about to get to. I'm going to Slack to you this. And this is a haystack. We have a variable called haystack, which is a hash. It's a hash that inside of it are arrays and other hashes. Now, if you look carefully, there is a needle in this haystack. So your exercise is to write code that will pull out the needle from this haystack, and then you can Slack it to me. Again, use my pro tip. Just dig in one level at a time, and as you dig in, see, is the needle still there? That means you're getting closer. If the needle's not there anymore, that means you lost the needle. You have to back up. Again, the good news is you'll never see this actual code in real life. But you'll see similar things, just not this brutal. Oh, I could have made this so much worse. Okay. Yikes. So, well, it seems like, again, the first thing we encounter is a hash. So it looks like everything, I mean, there's no indentation here, right? So again, if I could really sit here and indent everything and try to reason about it and arrive at the right conclusion, but sometimes it's just easier to just go with your gut and try it out. So, no P, thank you. So, okay, the needle, so we got back actually an array where the needle is there. So, yikes. So, I mean, it's so hard to even look at this, right? So, looking at 1 second, if we pull back the first item from here, we get the string hey. So that's a dead end. We need to go back up. So it looks like things are within here. And this seems to be the fourth item in this array. So since the index starts at 0, 0, 1, 2, 3. Let's see if that works. It does work. The needle's still there, and now let's see, we've narrowed our problem down. Yikes. Hey. I'm just gonna go with another hey at this point. That's what it seems.
Because there's two hashes, one hash that leads to another hash that then leads to the array that houses needle. So we definitely want another hey.
Yeah.
And we want another one too to open up the next set of serial ones.
Wow, this is brutal.
Cool. Now we've got, well,
now we're at an array, right? So it's gonna be 0, and it looks like 1.
Yep.
Getting close. So we're up to hash. So this hash has one key value pair in it, right? The key is the string hey, the value is an array. So we're gonna call this the key to get at the value. We now have an array 0, 1, 2. Yeah, there's our needle. Brutal stuff. Sorry. Other than a request, like, please don't give us this again. I won't. Okay, let's talk about the final topic for the course, which might be the most exciting topic. And that is something called an API. So you actually it doesn't matter what API stands for, but since it doesn't feel like the course is complete talking about an API without saying what it stands for, it stands for Application Programming Interface, which means nothing. Let's talk about what an API actually is. So you are all familiar with using the internet, something we've been doing since about the 90s. However, you may have not put too much thought into how it works. And we're not going to go very deep into it. Not that I even know deeply how it works, but you do know that you use the browser, right, to access the internet. So some of you use Chrome, some of you use Firefox, some of you use Internet Explorer, Opera, I don't know, all of the above. Safari. So here I'm using Chrome, but whatever it is, your browser that's your window into the internet. Now, the way websites are hosted on servers out there in the world, and your browser communicates with those servers. And the way it works more specifically, this is actually the way it used to look like in the 90s. It works the same way today, but with these icons, those are the 90s icons. This is your computer, or this was your computer, with Netscape or whatever, AOL or Prodigy, whatever you're using to browse the internet back then. And the website actually lives here on some server out there in the world. When you, let's say, go to google.com with your browser, that sends a web request to a server. Now, if you go to google.com, these servers are owned by Google. And Google gives back a response in the form of code. Now, this code is typically HTML, CSS, and JavaScript. You may have heard of some or all of those. Your browser then takes the HTML, CSS, and JavaScript and interprets it in order to give you a web page. So let's just repeat that life cycle. Your browser does really two things. It sends out requests and interprets responses. So when you go to google.com, that sends out a web request to Google server. The Google server gives back to your browser a web response, which consists of code, HTML, CSS, and JavaScript. Your browser is adept at understanding HTML, CSS, and JavaScript, and it mushes it all together in order to make a nice visual page that you can look at and click on things. Yeah?
And the servers, how much of them have to be tied to physical things, or can they be in the cloud, so to speak?
Yeah, great question. So all servers a server is really just a computer.
Yeah.
However, the computers that we use have screens and keyboards. The server is just like the computing part of the computer. It doesn't really, you could attach a keyboard and a monitor to it if you wanted to, but a server is just a computer. It's just the thing that servers specialize in are spitting out HTML, CSS, and JavaScript. Now, all websites live on a physical computer, on a physical server somewhere. When we talk about websites being on the cloud, that just means that, like when I host the Quizikistan website, it's not like I have somewhere, like in this vault, some server that the website is coming out from. However, what is going on is I rent basically from a service called Heroku. Heroku has a bunch of, and they actually rent it out from other people, like from Amazon. Basically, like Amazon, somewhere, maybe like by the North Pole, they have a ton of these servers. And I'm basically saying, hey, Amazon, can you host my website on one of your servers? I don't want to actually buy one of these clunky things. I don't have space for it. I don't want to maintain it. But I'm putting up my website on Amazon servers. But all websites do live on an actual physical machine somewhere. I might be the owner of it, or I might have Amazon hosted on their servers on my behalf. When I have it hosted by someone else on my behalf, that's what's called like cloud hosting. Yeah.
So, I actually have a question. Let's say the servers that host these sites, one of them goes down.
Yeah.
Are there certain, does it know to go or be redirected to another server?
Yeah.
So that's an excellent question. So Crystal's question, what happens if a server goes down? What happens then? It all depends on the setup. So there are some websites out there that are hosted on a single server, and if the server goes down, then the website is down. End of story. If you try to go there in your browser, it will say we cannot find this website. What more professional websites do is they have like a whole series of servers with some sort of infrastructure set up so that when traffic comes in, it gets directed to all different servers. If one of the servers goes down, that machine is immediately notified and only sends traffic to the remaining servers that are still standing. But it's up to somebody to set that up.
Right.
it is possible to set up a single server, and you're at risk for outage if it goes down. Does that make sense?
Yes.
No, but the main thing here, I didn't want to get too much into the depths of all this. The main thing you have to know is that the browser makes a request to the server sends back a response. The response comes in the form of HTML, CSS, and JavaScript. If we look at HTML, CSS, and JavaScript, we'll just see code. The browser knows how to take that code and turn it into this so that we can enjoy it more visually. Does that all make sense? Okay. Now, there's another part of the internet that we may be less familiar with. And that is that it is possible, and this happens all the time, that a server may not be configured to send you back to your browser HTML, CSS, and JavaScript. That's 99% of the time what happens. But you can also make it that your server sends back plain raw data in the form of arrays and hashes. Why would you want to do that? We'll get to that. But let me show you what on earth I'm talking about. So when I go to this website, Replit, languages, Ruby, I get back HTML, CSS, JavaScript. I can even type stuff in it. It's really cool. I can run Ruby. Awesome. When I go to Google.com, I get back HTML, CSS, JavaScript that is rendered as this. But when I go to this URL, which is not one you may be familiar with, data.cityofchicago.org/resource/blah blah 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 blah.json, I'm not going to get back HTML, CSS, JavaScript. I'm going to get back an array of hashes. Just pure, unadulterated data. What is this data? This actually happens to be every individual employed by the city of Chicago, because that is public information, including their annual salary. That's interesting. We could probably look up Rahm Emanuel, or maybe not.
Does anybody make under 100 grand?
Yes, George Ailman. Yeah. No, we're actually, I think Rahm is in here. I think this is not giving us back all employees, it's giving us back the first 1,000 in their database. But you could look up the mayor's salary. So here is Paul Allison, who's a full-time person for the pirate. Actually, Paul's is going to save someone right now. That's Paul. Hey, Paul! And he's making a good living by doing that. He's paid on a salary basis, making $107,790. This is an array of hashes. Each hash represents a person, and it's a list of people. So it's all these hashes are contained within one very long array. Now, why on earth does this website exist? It's not even a website, right? It's just data. And this will become a little clearer when we start working with this. But the answer is that you're right. For a human to browse the internet, they don't want to see this. But this URL is not meant for humans using Google Chrome. This is meant for programs that you write, for software that you write. Let's say you want to write a program, maybe you want to make a website that shows other people what the salaries of all the employees of the city of Chicago. How does your website, the one that you're writing, get that data? The answer is your website calls this URL, gets that array, and brings it into your code, and then you do whatever you want with it. This is called an API. An API is this concept that we call a URL, but instead of getting back the typical HTML, CSS, and JavaScript that is meant for human consumption, we get back raw data, which is meant for computers' consumption. Today we're going to be writing our own software that will utilize APIs. So we're going to make our own program that we're going to, I mean, we'll do a couple of programs today, but one of them, for example, is we're going to allow the user to type in their city and state, and we're going to tell them the weather. We're going to write another program today that allows the user to type in a word, and we'll be able to tell them its definition. How do we have that information? Because our program is going to look it up on the internet. How does our program look it up on the internet? Through the API. It calls the URL, gets back the raw data, and we, in our code, do whatever we want with that raw data, but we'll decide how we want to display that to the user in our software that we write. Yeah?
So when it calls the URL, is it going through the server, or is it a different
Yeah,
process?
it's going through the server. So it's the same process. The software, so instead of the browser calling the server, it's our software calling the server. And instead of the server is still giving a response, but this time the response is in the form of raw data instead of in the form of HTML, CSS, and JavaScript. Again, this will be much, much more clear when we actually use this in action. But this is the concept of an API. This is what an API is. APIs are super powerful. It allows us to write software that can pull information from across the internet. Right? We don't have the database that tells us the definition of all the words in the dictionary, but we don't need to. We could still write a website that tells you the definitions of words, because all our website has to do is look it up from an API. That API has a database. So when we're calling this City of Chicago API, the server that belongs to the City of Chicago, in that server, there's a database. Or that server is talking to some database that it has. But we don't need to be the owners of that database. We're just borrowing that information from the City of Chicago server. And then we're displaying it in our own software. Does this make any sense conceptually? What? Kind of, yeah. It's one of those things I think will become clearer throughout the day. Now, this actually has this format. I've been just calling it raw data, calling it arrays and hashes. This is actually known as JSON, which stands for JavaScript Object Notation. Basically, APIs, the raw data that you get back can come in different forms. This particular form is JSON. JSON is super easy to understand because we already understand arrays and hashes. JSON is always just a bunch of arrays and hashes. So I'm not going to go through the other types of APIs, but this is the most prevalent and common API that exists. It comes back in JSON format. Now, I'm going to Slack this very URL to you. Now, you'll notice when so I want everyone to pull this up in their browser. You may notice that it doesn't look as good in your browser as it does in mine. And that's because I'm using a browser extension that takes the data and makes it look pretty. Now, I don't know which browsers you're all using, but pretty much every browser, I don't know if this is true, many browsers have many extensions that do this kind of thing. If you're using Google Chrome, there's many options, but one of them I'll Slack out to you. If you want to just take a moment to install it, it's called JSON Viewer. So here's, you already have it? Sweet.
Yes, I must have.
You must already have, what browser is that?
Chrome.
Chrome? You must have already, is it possible you were here for the API meetup?
No, but I've done meetups before.
Okay, so you already have it installed. Yeah. So if you're using Firefox, you could just Google Firefox JSON Viewer, and you'll see some sort of extension come up. It's not critical, but it's really nice to have when you're looking at APIs. It makes it much easier to read. Now, APIs really aren't meant for humans to read. They're meant for software to read. But when you're developing the software that is going to read the API, it's super useful to be able to make sense out of it for yourself. So we'll just give you a moment for those who want to install such an extension for your browser. I don't know for sure if Safari has something like that, but I know that Chrome and Firefox certainly do. I'm sure if you just Google JSON view generally, there might be even websites where you could put JSON in there and it formats it for you nicely. Okay, let me demo another API. It's just another example. And I just want you to tell me if it looks familiar. Does this API look familiar to you?
Yeah.
So we've been dealing with this, right? This is the weather. Now this is not the weather for Nome, Alaska. This is the weather for Chicago. Let me Slack to you this URL. Hey, what's up?
Can I borrow one of the whiteboards?
Yeah, for sure.
Because the big ones,
Are they in here?
we're finding one. Just these.
Oh, these, yeah. Take whatever you want.
Okay, thank you very much.
No problem. So let me Slack this one to you as well. This is the current weather in Chicago. We can see if they're right. The wind chill is 81. The temperature is 80. And it's breezy. Sounds about right. And here we have the 10-day forecast. Now again, this is not what you and I would go to look for the 10-day forecast. We would Google weather.com or something like that and look at it on a website. But this is the 10-day forecast in raw JSON form. And this is getting it live from Yahoo. Does that make any sense?
So if we
Yeah.
wanted to create a website.
Yeah, we are going to be creating
that
a...
had like weather currently in the 10 biggest cities in the U.S. We could pull from this data.
That's exactly right. And we're about to write a program, not a website. We'll make a more like a terminal kind of program that pulls that data for the user. Yeah.
Out of curiosity, it seems like the part at the top where it has like the two backslashes over at the top.
Here, yeah, the
Is
URL.
that what generates all the following subsequent code, like the part that links to, say, the Yahoo weather website that then pulls all that information from there?
So what's your question exactly?
At least in my browser, because I'm using Windows with Chrome,
Uh-huh.
and I'm seeing at the top there's like a double backslash, like the very top. We're talking lines 1 and 2 of the code. Okay, it doesn't like.
Oh, here?
Yeah, it's interesting, yeah.
Here?
No, not that.
That.
Line,
Yeah, I know what you're talking
so
about.
line 5 is where query is, but line 4 is, you'll notice, where the hash begins. So
Here, yeah.
lines 1 and 2.
Oh, I don't have a 1 and
You don't
2.
have it.
Oh, okay. I was wondering.
What does it
Looks
say
like
there?
Like a number recorded that would, like Shane's saying, that defines what you're pulling, Chicago weather versus San Antonio.
Yeah.
versus-
Oh, I don't know. I'd have to see that. It is not part of the main response. Otherwise, I'd be seeing it. Now, I do want to point out here. I mean, this is a very long URL, but if you look carefully, do you see right here, Chicago, Illinois? If we replace that with any other city and state, we will get back the information for that other place. So just give me another city that I could spell.
Houston, Texas.
Houston. So Houston, Texas. Yeah, here's the weather for Houston. You can fill in any city state. And as long as Yahoo has information on it, they will give it back. Questions?
Is this a sort of public service?
Yes.
Like just they do this.
Yeah, so some APIs are public service. They're free to use, like this one. I don't know their full agenda of why they make it available. It's not like Yahoo's a nonprofit or anything. There are APIs where you have to pay in order to use them. There are businesses that their whole business model is that they sell the rights to use their API. They collect data. Like ESPN has an API. It's not their whole business model, but if you want to get the latest, sports statistics and pull out data from ESPN, you have to pay hundreds of dollars a month to be able to access that. So some businesses, that's what they do. They sell the right to use their API. But this one's free, and yeah, it's up to them, the people who own the API, it's up to them how accessible they want to make it. Other questions? Eventually, if you do pursue, learning more about development, you'll be able to create your own APIs. So our students create APIs. They use APIs, they also create their own that other people can use. Okay, so let's okay, the next step is for me to show you how we, in our software, can access the API. But let's just take a quick break before we do that. So let's meet up at 7:12. Now, the next thing we're going to do is demo how you can use an API from your own Ruby programs. Now, there's one really unfortunate thing, which is that we are unable to use Replit to do APIs, just because of particular constraints they have on their server. However, I found another website very similar to Replit where we can work with APIs. So we're going to be switching over for the last day to this alternative to Replit. I'm going to Slack you this. It's called codepad.remoteinterview.io. And there's a particular example that I Slacked out to you. Let me pull it up here. Do you all see this when you go to that URL that I Slacked out? Okay. This works very much like Replit, just different colors. So you write your Ruby code here on the left-hand side, and the terminal is on the right-hand side. It's pretty much the same thing as Replit. However, this particular program will allow us to work with APIs. Okay, but it's a very similar concept to Replit. Okay. I have 3 lines of Ruby code right here. And now I'm wondering if there's a way we can do word wrap. Maybe one of you will find how we can. Those are settings. I don't know. Because it's a very long line of code, this third line. But let me introduce you to these 3 lines of Ruby code. We've never seen. Oh, this is dangerous. Okay, this is cool. We're all connected to this. So this is not like Replit. We're all connected to this. If one of you deletes something here, it'll delete it from my screen too. So that's cool. That's cool. But that's not what we want to do. Okay, so just bear with me as we use this new platform. I have 2 lines on the top here called require net HTTP and require JSON. It's not too important to get into that. Let's just treat it as magical Ruby gobbledygook we have to start with in order to work with APIs. But just to explain it briefly, when you work with the Ruby language, there's 2 parts to the Ruby language. There is the core of Ruby language, and then there's extra libraries that you can use as well. The way Ruby works is that by default, you're only working with the core language. If you want to work with one of the extension libraries, you have to require it to bring it in. The reason for this is that in most cases, they assume you're not working with any of the extension libraries, and it saves memory if you don't have to bring in those libraries. But to work with APIs and to work with JSON, we have to bring in these 2 external libraries into our basically our workspace. So that's what those do. If that didn't make any sense to you, that's fine. Just accept it as we need those first 2 lines to get the ball rolling here. Now, this is unfortunately really hard to read, especially when I highlight it like that. This json.parse net : http.get URI, lots of parentheses. This also, so we learned about functions in the past couple days. When this json.parse is a function that comes with these libraries that we brought in. So we learned how to make our own functions, right? We've been defining functions for the past 2 days. But we really haven't really explored the fact that Ruby comes with its own functions that you can use. And basically, these functions here, which we don't really need to understand too much how they work, but basically what they do is that they make a web request to this URL, this very long URL in this case, and get you back the result in the form of either a hash or array or whatever that API is. So this URL here is the very same URL we dealt with here, except that we dealt with the city of Chicago instead of Houston. So I'll pull that up again. Chicago, Illinois. So this is the current weather for Chicago in the form of a hash. This is the API. When we do this in our code, we call this very same URL. We get back that same hash here. Here we're using P to print it out. I'll, as just showing you that this is just a hash like any other hash. I can call this variable, I can call it Fred. Fred equals this hash. And now I can do stuff with Fred. I can print Fred. I can dig into Fred. So let's look at remember how we got the current temperature? We can do that in our code here as well. So instead of calling this Fred, let's call it weather. And now I'm going to copy this code and run it. It is currently 80 degrees in Chicago. Okay, so you already knew how to do most of this before today, right? All we're doing, the new concept from today is that our code can pull a hash from across the internet and work with it. That's what the API is. So yesterday, the last assignment from yesterday, I gave you a replit that had a hash in it, and I told you to work with it. The new concept from today is that we can get live hashes of data and arrays of data from across the internet in real time and work with it in our code and create programs that do miraculous things or semi-miraculous things. So if I wanted to get the wind chill, that's a terrible example, but what do you think? So if it's 80 degrees now, what do you think it is now with the wind chill? Who thinks about the wind chill in the summer? Is there wind chill in the summer? We'll find out. With the wind chill, it goes up a little bit, I guess. I don't know. Any questions about this? This is basically like tying everything we did together. We're pulling a hash from across the internet and working with it. Yeah?
So what you gave us yesterday, that was an API.
What I gave you, I just copied and I just called an API. I copied and pasted. I took it from API. I copied and pasted it, put it in a replit, and gave it to you, but it wasn't live.
Okay, so it has to be live to be an API.
Pretty much. I mean, an API is grabbing that live data across the internet. It doesn't stay live once you have it. Like if I just let this sit here and come back tomorrow, it's going to stay here, but I'd have to run this again to get the latest and greatest. Now some APIs aren't updated as frequently as weather, There are APIs that keep track of all the different Pokemon out there, and I don't know how often that gets updated, but the same API calls you make to the Pokemon API will probably be the same tomorrow as it is today. And they might just update it infrequently as new Pokemon are developed or whatever they do with Pokemon.
So are you saying an API is the data itself and we're calling the API?
Yes, I use the term calling. So it's basically, the API is the fact that we can pull data from across the internet
So it's
and
not
use
the
it.
data.
Yeah, no. the API, I wouldn't, in terms of like of how to like say it,
Yeah.
the API is not the data per se. The API is the fact that we can get data. But the data is just called data. But the API is the concept that we can call a URL and get back data. But the name for the data is just called data. And people do use these terms sort of loosely, you know. I might talk about the data and call it API, but that's not necessarily technically correct. Okay, questions about this? So I'm going to actually, so the exercise we're going to do now, we're going to have to figure out how to use this platform because we're all going to be overriding each other's stuff. I think we're going to have to figure out how to create our new ones. But the exercise is, so exercise number 1, I'll Slack it to you. And it's almost done over here, but is to create a program that tells you the current weather in Chicago, specifically 2 points of data. It should tell you the current temperature, which I guess I've already given that part away here, but also tell you the condition. The condition is this, the breezy. So the condition, when I say condition in exercise, I refer to this text within condition. So if you want to make your program a little fancier, you can like have some like, you know, the terminal can be like, well, welcome to my spectacular weather program. The current temperature is 80. The current condition, the conditions are breezy. So, you know, make it a little fancy. So maybe you can help the first, so see, one of you is editing this, which is fine. We need to figure out a way to create a new one. I had no idea that this would happen because I was just trying this on my own. Yeah, you know how to do it?
Something that I did,
Yeah.
all I did was I took the URL, or all I really did was just copy codepad.remoteinterview.io into a separate window. So
Uh-huh.
Just took out everything after.
yeah, and so what
So if you just go here,
Yeah, I think that's.
so let me Slack that out to you. So if you go there, whoops. If you go to the URL I'm slacking to you, that brings you to a new CodePad, I think, does it? And then copy and paste some of this code from here. Wait, hold on. Let me do it. Or I'm going to put this, it's sort of awkward, I'm going to put this in a replet and give it to you so you have a good place to copy and paste it from.
Also, when you're starting your new codepad.io, make sure to select Ruby in the lower left, because I think it defaults to like C#. So.
Okay, so let me walk you through that. So when we go to the new CodePad, I was so bummed that we couldn't do this in Replit. So you can do a new pad. Yeah, so by default, as Shane pointed out, it's C#. So you want to change that to Ruby, which you can do by clicking on this tab below and then going to Ruby. And unfortunately, it's not in alphabetical order, or it is just for part of it.
Just to check, the code you put in Replit, the weather API is for Chicago, not for Houston.
Yeah, I believe so. Okay. We want to just make a program that tells us the weather in Chicago, specifically the temperature and the conditions. So, I mean, we're mostly there. We're going to say, welcome to Weather Channel. Yeah, I'll make something up called the Weather Channel.
You're going to be a millionaire.
Yeah, I like it. We'll make it exciting. Today in Chicago, it is. Now, I'm going to put this in the middle of my sentence using interpolation.
Yeah, okay, yeah.
So, ooh, I don't see how I did that. That's Control Command up and down. You can move a line up and down. Okay, that's totally not the point of this. Okay.
How do you get that line of code? To
Yeah. So let's.
in the, yeah.
So if this line of code gives us the temperature, which it does, let's perhaps store that in a variable. I'll call it temperature equals that, and then we'll interpolate. It is temperature degrees. Let's run that. Welcome to the Weather Channel. Today in Chicago, it is 80 degrees. Now, let's get the...
Oh, that's cool.
Let's get the, what is it? The condition. Condition equals... And this is probably the hard part of the exercise. And I think I'm just gonna, I'm gonna let you walk me through how this one works. It's, what is it? Weather, query, results, channel, item. Whoops. Let's see what that gives me. I'm going to comment this out. Ooh. So this gives me... Is it condition is the next thing? Let's see. Yeah. And then text. Okay. So now that we have that, I wish this thing did word wrap. Okay. Today in Chicago, it is temperature degrees, and it is something outside. Now what will happen when I run this code? It's not going to work because, or it's going to give me an error, right? It's going to say, error on line 7, undefined local variable or method condition. Problem is on line 7, I refer to condition, but I didn't define it yet. So I need to define this earlier. And now when I run it, welcome to the Weather Channel. Today in Chicago, it is 80 degrees and it is breezy outside. Breezy with a capital B, yeah.
Yeah, I was going to ask, is there a way to change that?
The capital?
Yeah.
There is, with the way I don't think I showed you, but we can do condition dot down case.
Oh, that's cool.
This is something called a method, which we didn't talk about, but Ruby comes with a bunch of methods, that little tips and tricks to make life easier. Does this make sense? Questions about this?
Could you select just the temperature and condition thing in Replit just for like the format?
Yeah, let me, good idea. I'm going to put this whole thing in Replit. This is so annoying that we have to do that, apologize, but let me just show you what happens when we try to run this in Replit, just to explain why we're not using it. Failed to open TCP connection. Basically, Replit does not allow you to use their servers to make an API call elsewhere. They sort of blocked it. But I'm selecting to you the Replit that at least contains that code that you can then put into this other platform. Okay, now let me show you how we can make our program much more flexible. Right now, our program is limited to Chicago, which is nice for us because, at least of those of us sitting here, we're all more or less Chicagoans. But what if we want to make a program that could tell you the weather anywhere? That'd be pretty cool. So we're 99% of the way there. Let's do it like this. Welcome to the Weather Channel. Please enter a city. Do you remember how we get the user to enter something? Yeah. So we're going to have the user enter a city, and we're going to store the user input into a variable called city. Then we're going to say, please enter a state. And we're going to get.chomp that and store that in a variable called state. Now, watch this. This is where the magic happens. I'm going to move this line down where we make the API call. And remember that there's a place in the API where we specify the city and state?
Wait, can you
Sorry.
the code pad?
Yeah. I mean, yes. Here, let me put this in Slack as a snippet. Okay, you should have it now. We have to find where in the API we specify the city. Here it is. Yeah. So instead of explicitly putting Chicago in there, we're going to interpolate whatever city the user entered, which is now stored in the city variable. And we're going to replace this Illinois with the state that the user entered. Now, one catch here is that it looks like the user has to enter it as just the abbreviation of the state. So let's see. Let's see if this works. So I'm going to say, please enter a state abbreviation. I hope this works. Undefined method chomp. On line 6. It doesn't like gets.chomp. Why not? Does it not let us do gets here? Oh no. Hold on. No. Let's make sure our code is right. Yeah. So the question is, why do they not allow gets.chomp? Hold that thought. I want to finish this complete thought, and then we'll worry about getting it to work in this platform. I'm going to move this to the text editor. So hold on. Oh, so Chris has a suggestion. It's because you can't. It's in general. It's you can't type on the right-hand side of that website. So that website is not allowing us to do that. I'm going to make it work on my desktop, on my computer, and then we'll worry about getting it to work there. So I'm going to make, hold on one second. So now you get to see how you make Ruby programs for real. So use the text editor like Sublime Text. I'm going to dump my code in here. I'm going to save it as a file called weather.rb. And this is our program. This is the equivalent of the left-hand side of like Replit and this new website. To run my program, this is the terminal. So whereas in Replit, it has it all on one screen, right? Your text editor on the left-hand side, the terminal on the right-hand side. In reality, it's two separate programs. If I wanted to make it look similar, I can So here's the code on the left-hand side, and here's the program on the right-hand side. So I run the program by saying Ruby space and then the name of the file. And am I on the right? Hold on. I didn't save this to the right place. I don't know where I saved it to. Okay. So now we see, welcome to the Weather Channel. Please enter a city. So I'm going to say, give me a city. Besides Chicago and Houston.
Middlemark, Alaska.
You beat me. Denver. What's the state abbreviation? CO? Today in Chicago, we'll have to fix that. It is 84 degrees and it's partly cloudy outside. But that's the weather in Denver. The reason it said Chicago is because we wrote Chicago. So let's replace that with your city, right? Let's run that again. Give me another city besides Nome, Alaska. St. Louis? Give me without spaces because I don't know how that's going to...
Tulsa.
Tulsa? That's Oklahoma, right?
Yeah.
What is that, okay?
Okay.
Yeah, in Tulsa it's hotter. It's 90 degrees. And it's sunny. I mean, so we've just made a really significant, flexible program. You can enter any city-state, and it tells you the weather. That's pretty cool. And we can, I mean, we're just giving you two pieces of information, right? With the API, we know we can give you the wind chill and other exciting things like that, too. Yeah?
So is this restricted to only today's data, or does it update?
Every moment. I mean, so different APIs are different, but I believe the Yahoo Weather API is updated constantly.
Okay.
Yeah.
So even if you save this file, I can get.
Yeah, if I run this,
other using this.
yeah, if I run this an hour from now, even in the same city, I'll probably get a different result.
Okay.
Yep. We can also give the 10-day forecast, right? We can, I mean, you all know how to do this now, right? If I said write a program that gives you the 10-day forecast for any city, you could do that. I mean, you'd have to spend some time pulling that data from the API and taking the array and formatting it, but I mean, this is a complete program. Now I just need to figure out how to get it to work in the online thing. That's weird.
So if we were
Yeah.
to,
Go ahead.
so if we were to take this program
Yeah.
and then we could send it to a server, and then we could, through JavaScript, we could create through a browser like a website, or how would we?
Sort of. So this when we just write plain Ruby code like this, the only way you could run it is in the terminal like this. But yes, if you could wrap this very similar code into like Ruby on Rails and deploy it to a server and have a website that does the same type of functionality. Yeah. So like in the bootcamp, like we show you how to do that. Like take this and make it a website. Other questions? Risa, if you can, well, just trying to figure out, because I have an exercise for you that I want you to do this, but the get.chomp is like, I believe I found another, hold on, let's try this. Give me one moment, I apologize. Here's another one. Super ghetto. Compile Ruby online. Let's see if we can run a basic program here. Run it. Hello world. Can we do gets.chomp? Oops. I need some way. Oh. Process killed. Run. Yeah. I need to find a way to get this. Let's take a 10-minute break while I work on that, and then we'll have the exercise. So I invited you to Cloud 9. When you're at a space like this screen says Workspaces. Create a new workspace. You'll click on that big plus. You can give your workspace a name. We'll call this, I don't know, whatever you want to call it. And I think you should, Risa, am I right? Should you click on the Ruby thing? Risa?
Yeah.
Is Ruby the thing that you need to click on?
You can actually just do a blank
Blank?
workspace, and then you can just create your file. Because if you do Ruby,
It loads those
it'll load
libraries.
the whole app.
Oh, so how do you do it blank?
So down below next to the cat, it says blank.
Oh. Okay, so everyone choose a blank workspace. And then hit the green Create Workspace button. We'll take a few moments for it to load.
Which one, Jen? Because it's on each now.
Blank. It's the second to last one. So we got experience with a lot of different environments today. So, okay. What I think you do, and maybe Risa, you can correct me if I'm wrong.
You just need to do closing.
Okay, that's okay.
To create,
Way of telling me there was a wrong section program.
so Risa, I'll let you teach this part.
So
How do you create a Ruby file?
right click on top of your folder.
Okay, so everyone has a folder here on top based on whatever name you gave it. So right click it,
And it should say new file at the bottom, second to last.
and then you click on New File.
Hopefully.
And you give it a name. So we're going to call this.
Any name, but make sure it's lowercase and put a .rb.
Okay.
Oh, no symbols, I meant.
Okay, we're going to call this dictionary.rb. So any Ruby file typically ends with .rb. Once you have that and you click on it, or maybe double click on it, it pops up with the text editor where you can type in Ruby code.
How do you name the file?
So when you right click and hit New File, it automatically pops up with a blank or with an untitled thing. You just fill in the name. So this is one step closer to a real environment versus something like Repl it. So the way this works is this top section is the file. This is your text editor. And the terminal is this blue thing on bottom. To run your file, you type in the word Ruby and then your file name. So I'm going to type in Ruby space dictionary.rb. Oh, man. Oh, I didn't save this.
How do I exit out of the program?
Let's try that again. And it says hello world. I just want to first make sure everyone's able to get a hello world up.
If we have Sublime, can we just do this in Sublime?
Yeah, are you able to run Ruby from your computer?
Yeah. I have a Mac.
Okay. Yeah.
It's in.
Yeah. 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 Yes. If you already have stuff on the computer, you can totally use that.
I went through some of your videos.
Okay. Good. Cool. Is anyone unable to get a hello world program running in their terminal?
Just type Ruby, dictionary,
Yeah, and that
What's the difference between tabs, bash, immediate, dictionary? What's the difference between those?
You just,
Thank
I think
you.
it's just, because mine is also, I think it's like.
Oh, so you have a rail.
A theme you could choose. So, this, you're typing
Anyone unable to get this up and running?
Yeah, the only time you write it is when you write it. No, and then it'll come. So this is like, yeah, this is what you were seeing on the side.
I just typed it in again. I don't know what's going on this time. Maybe it wasn't saved before.
This is like your
It is working.
your computer actually has one.
Okay, I don't know how to hit terminal. So when I hit run, this tab.
Oh, so you don't hit run. The way you run the file
But
is...
don't hit the C, right? It's run.
Yeah, don't hit
Yeah,
run.
run is
You
actually
do that.
for an app.
Maybe
So it'll start running.
Oh.
that's how you run it.
Okay.
Yep.
So then you get a new, you get a new tab popping up. Oh, there it's okay. Yeah, but in the other one, in Cloud 9, it's not.
So you're good?
Yep. I even got my old weather map.
That's fine. Cool. Kathy, you're good?
Mm-hmm.
Okay. We're all good? Okay. So now the exercise is to pair up and create a dictionary program using an API, which I will show you now. There's an API called the WordNick API, which I will Slack to you. Now this is an interesting, the documentation so I Slacked it to you. I'm going to pull it up here. This is a dictionary API. When you go to this site, you'll see 5 sections here. Click on the section that says word in the singular, not the words in plural. This is API documentation. It shows you how to use their API. If you click on, well, watch this carefully. I'm going to click on this third one, this definitions. So it tells you on the right-hand side what each of these URLs do. So if I click here, this is the return definitions for a word. It looks like a lot of gobbledygook, but it's really, you'll see how simple it is. I'm scrolling down, and see where it says word? I'm going to type in a word. Let's say bubble. And then I'm going to scroll further down and say try it out. What that does, it gives me this URL, and it actually shows me the hashes and arrays that this URL would give me back. If I wanted to, I can copy and paste this URL into a new tab in my browser, and I would see the same thing. So this is calling an API across the web, getting information about the definition of the word bubble. And it looks like this is an array of hashes. It looks like it's an array of multiple definitions, right? Because bubble could have multiple definitions. It could be a spherical or hemispherical film of liquid blah, blah, blah. It could be a globular body of blah, blah, blah. Yeah. But it could be something insubstantial, groundless, or ephemeral, right? There's different definitions for bubble. So this is an array of all the definitions for the word bubble. If I go back to the documentation, I can try out some of their other things. This is a URL that returns examples for a word. That looks pretty cool. There's a similar one. Let me close this one. Here's one that returns a top example for a word. So let's try this one out. I'm going to type in bubble.
Which section is this?
This is the 4th one, the top example. Try it out. And this is just, I don't know, this is taken from a book. And it has the word bubble in it. It's an example sentence. Let's see what else this API has. It returns the pronunciations for a given word, the syllable information, the word usage over time, etymology data, the audio metadata for a word. Let's try that one. Bubble. So this gives me back the audio data. So what does that mean? It looks like it gives me a file that if I open this up, this URL in a new tab,
Bubble.
yeah. So the JSON, if it's, it's just arrays and hashes, it can't give you the audio, the actual audio in there, but it can give you a URL that brings you to an audio file that says the word bubble. So it's pretty cool. This is what APIs are like. A lot of APIs are well documented. You could play around with them like this. Some of them are really poorly documented. It's really hard to figure out how to get them to work and what they do. But what I would like you to do is pair up with a person next to you and create a dictionary program that asks the user to enter a word, and your program will give them all sorts of information about the word. Now, things that you obviously want to have in there, so I'll give you some recommendations of what to put in, but you can feel free to make it super fancy and give them all sorts of information. So I would recommend giving them a definition. I'd recommend giving them a top example, maybe a pronunciation, and if you want to get fancy, make all these different API requests to get back all this information about the word and present it in an easy way to the user. Does that make sense? So I'm just going to slack to you the minimum. So exercise, create a dictionary program that returns, or that asks the user to enter a word, and it returns the definition, top example, and pronunciation, which I'm going to spell wrong. Does that make sense? So pair up. Remember, when you pair, one of you is operating the computer, one of them is talking to you, and use as the basis of this. What I have here. Let me take the latest of this and slack it to you as a snippet, so you have this weather example as sort of a baseline to work with. Joseph, you had a question?
Yeah, so it's not like with the weather example how it's sort of pulling all the information from all the cities, or how does it pull from all the words possible?
So you're just going to enter one word, and then it's going to get you information about that word.
Okay, so
The user's going to enter just one word. Mm-hmm. Yeah.
In this program, can we still note things like with hashes or with hashtags? Like, you know what I'm talking about? Like in REPL, where you can
Yeah, comment, yes.
out,
Yeah,
that's the
yeah,
word.
yeah, yeah. In Cloud9, you could do everything. So apparently in REPL you could do gets that chomp, but you cannot do APIs. In this one, you could do APIs, but not gets that chomp. And Cloud9 resembles the real-world environment where you can do everything, I think. We'll find out if there are any limitations. So everyone pair up. So I guess Crystal, you can go with Joseph. Ethan, go with Sam. Cassie, you go with Josh. Robert, Sandra, and Shane, you go with Evelyn. So this is a team project. The entire class is working on this together. So that doesn't mean that we're going to go off into our little corners and try to figure it out separately. Basically, one of you or some of you might step up to use my computer to try to put down Kazakhstan, with everyone contributing ideas, because there's definitely a puzzle aspect to this. This is a combination of programming and puzzle solving and teamwork. And basically the last item we need to take care of is the nuclear program. We basically have discovered that Kazakhstan has a nuclear weapons reactor, which I don't even know what that is, but it sounds dangerous. Has it actually somewhere hidden in the United States. And if it explodes, that's super bad. So we need to put that down. Now, unfortunately, in order to get into their nuclear program, you have to enter the password. Now, we put together the best and brightest from the FBI, the CIA, the what's it called in England? The M something? MI6. And other countries all working together to crack this password, and we finally got it. The password is password. So we got it. Okay, so we need to figure out where their nuclear plant is located and how to put it down. That's all my instructions for now. As we get closer, I'll give more hints.